So this is a 5.3 LS inside of a Lincoln MK7. We are looking at the throttle position sensor. It is a drive-by-wire throttle body. And so our throttle position sensor has 3 wires coming out of it, our black being our ground, our yellow being our signal, and our gray being our volt reference. And so as you can see, I'm connected to the yellow wire. That is giving us 0.03 volts. Our ground is going to be giving us 0, and our signal ref is giving us 5.034. As you can see, our wiring diagram is not for a Lincoln MK7. It is for a 2000 GMC Yukon with a drive-by cable instead of an electronic throttle, which the later ones had. That's what we had trouble finding, a proper wiring diagram. However, as you can see on this bottom left, our TP sensor signal comes through a pull-down resistor and then goes up into the throttle position sensor through that C, and then our TP sensor 5-volt reference comes out of the other part of the PCM and goes through that A, and then our TP sensor ground goes through the B, and they all go from fixed resistors to that variable resistor within the throttle position sensor. As you can see, now we have the throttle position sensor plugged in, and we are reading on our signal wire 0.62 volts. And so when we open that throttle, we see it increase, and that is throttle all the way open at 4.2. And then if we change to our voltage reference wire, we get 5.034, and when we open the throttle, we see no change. So right now we are using a picoscope to look at the live voltage wavelengths, the TPS signal wire when we increase the throttle. And so right now we are at no throttle, and as we slowly increase, we go up and increase our voltage, and as we decrease, we go back down. So what we are doing here is we are trying to create a code within the circuit, and so we are taking this wire and connecting it to our signal wire, and then taking this test light, connecting it to our VREF with everything grounded and the key on. And then if we do that, we're creating a short, and then we can come into the vehicle, look at the scanner, and theoretically we should have a P0122. And there it is.
Okay, so this is our 2017 Subaru WRX, and today we're going to be testing the ECT sensor. So as you can see right here down below the manifold, this is where our ETC sensor is located, and we are currently pinned in on the signal wire and grounded over here on the battery. What we've got hooked up here is our multimeter to read the voltage signal, and as well as the actual OBD2 reading of the temperature, which is currently at room temp, which is 68 degrees. So now what we're going to do is we're going to start it up and let it warm up and idle, and we will see the change in voltage that happens as the car is warming up. So as you can see here, this is our Subaru WRX's ECT sensor circuit. So starting at the top here, we have 2 fuses that power originally runs through, which then goes straight into the combination meter or the gauge cluster. Then it splices off into 3 separate transistors, which then lead to several different places, in mostly the microcomputer, which then relays data to the engine coolant temp gauge in the gauge cluster. However, power also then goes through to the CAN transceiver and receiver, which are the network communication lines used for different modules to communicate with each other. Also, on this side of the microcomputer, there is also the reference to ground for the entire circuit. And if you follow these CAN transceiver and receiver lines, they go straight into the PCM. And on the other side, the engine coolant temperature sensor, which only has 2 wires going directly into the PCM as well, which would be our signal and our ground.